This is a Math 24/7 7th grade lesson, plane geometry and similarity. Lesson 2, area of a circle. So area of a circle is different. We did circumference of a circle in our first lesson. That is the perimeter around, or the fence around, a circular area. Today we're going to do area of a circle, and that is sort of the grassed in part, or the inside of the circle. So as we begin, we're going to think about this in a little bit different way so we can see the circle pulled apart, and we've got a nice visual here. So Professor Smart is teaching her students how the formula of an area of a circle was derived, was figured out. So she took a circle, cut it into equal pieces, and rearranged them from this shape here and just put them all together in a line here. Hopefully, you can see a certain figure. So first question we want to know is there a 2D figure that you can see it's very similar when they're rearranged? Hopefully, you can see that it is a parallelogram, right? Oops, let me get a marker here, a parallelogram. And when I say that, it's not a perfect parallelogram because the lines aren't straight. But if I did this, hopefully you can see that parallelogram, kind of filled in. And that really kind of makes it a visual. So I'm going to erase this now so you can go back to seeing that. I just wanted you to kind of visualize that whole thing as a parallelogram. And the next part is, what formula do you have for a parallelogram? Well, the parallelogram formula is area equals base times the height. So remember, just like before, the height is this part right here, right? Which is the distance. So the next question wants us to know, how is the circumference of the circle related to the length of the parallelogram? Well, hopefully you know if you do 1, 2, 3, 4. 1, 2, 3, 4. Okay, so there is the base. So the length of the base is half of the circumference. So there's 4 of those. So length of base, okay, is half the circumference. Okay? And because of that, we know that we can fill in 3 different ways. We know that 1/2 the circumference times the radius. Then we can go down here and say, well, we know that circumference equals pi 2r. So we can put that in for the c. So we're going to replace that with pi 2r times another r, which is already there from right here. And if we combine this, we have pi r squared, because 1/2 times 2 is 1. So let me get another color. So this and this cancel out. R times r is the same as r squared, and pi is left. So here is our formula for the area of a circle. So area is the surface measurement of a 2-dimensional figure. It is the square units that cover a circle. So we're going to use this formula, area equals pi r squared, where r squared, remember, means r times r. It does not mean 2 times r. That's very different, and you will get a very different answer. So please be careful. This is a common mistake right here, that instead of this, we do 2 times r. All right, so now we have a formula, just like we did with circumference, and now we're going to find the area. So always start out with the area, writing the area, and this is pi. And now we're going to plug in the values. So area equals pi 3.14 times the radius squared. In terms of pi, it is pi 3 squared. And if we multiply this out, 3 times 3 is 9, and 9 times 3.15 is 28.26, and these are inches, and it's squared when it is area, okay? Same thing, we're going to use the same formula, area equals pi r squared. Our plug-in values are pi is 3.14, radius, if this diameter is 10, be careful you don't use 10, we need a half of that. Half of 10 is 5, so it's going to be 5 squared, so it's pi times 25, I should put, let me go back here and put 3 squared is actually 9. That kind of puts it a little bit more perspective. And then if you do pi times 2.25, it is going to be 78.5 centimeters squared. And example number 3, same formula, area equals pi r squared. Pi is 3.14, 6 squared, so it means pi times 36, because 6 times 6 is 36. Be careful you don't put 12 in there. If we multiply that out, we get 113.04 meters squared. Pause if you need to pause, if you want to get this written in, if I've gone too fast, or rewind if you need to. All right, now we have a couple of questions that we don't have the pictures. So a circle has an area, okay, so that means the area is equal to 78.5 square inches. If you need to draw the pictures, what is the radius? All right, so we're going to use the same formula, but this time, where 78 is going to go over here, 78.5 equals, we know pi is 3.14. What we don't know is what the radius is. So this one's a little bit tricky, and I'll kind of show you how we go about doing this. First thing, it's a one-step equation. We need the r by itself. So to get the r by itself, 3.14 is being multiplied by r. So the opposite is to divide both sides by 3.14. And when we do that, we get 25 on this side. Now, in your calculator, you should have a square root button that looks like this. You can put 25 in and hit the square root button, or sometimes you have to hit the square root button and 25. But remember, r, all that means is r, something r times r, and it has to be the same number. If you know your multiplication tables, we all know that 5 times 5 is 25, so 1r would be equal to 5. So a couple ways to look at that. And I think most of the examples will use easier ones so that you can figure them out very quickly, because we know what two numbers equal 25 that are the same. Number 2, we have a circular sprinkle system in the wall. This one has an area of 28.26. So we're going to use the same formula, pi r squared. Area goes in place of the a. 3.14 in place of pi. Now we're going to get rid of the 3.14 from both sides so we can get our variable all by itself. And 28.26 divided by 3 is 9. And we know that 3 times 3 is 9. So r is going to be equal to just one of those 3's. Hopefully that makes sense. The same thing, you can use the square root symbol and do that for 9 if you're not quite sure. That's another way to do it. See me if you need me to show you how to do this on your calculator. Number 3, Jada says that if you were given the circumference of a circle, you have enough information to find the area. Is Jada correct? Well, let's look. Circumference is pi times the diameter. So if you are given the circumference, let's say the circumference is, I don't know, 5, okay? And we know this is 3.14. Could we find the diameter? Yes, we can. So we can find the diameter. If we have the diameter, can we find, whoops, we want area. pi r squared. If we have the diameter, can we find the radius? Yes, we can, because the radius is equal to 1/2 of the diameter. So why can we find it? Because it allows us to find diameter. If we have diameter, we can find the radius. And if we have the radius, we know what pi is. We can just follow the formula. So yes, we can. She is correct because of the reasons we just talked about. You don't have to add anything in here if you don't want to. Just know that because you have one, you can have the other. So the last part we're going to talk about here before we do one last problem, word problem, is we have to determine whether we're finding circumference or area based on each example. So the amount of fencing, anytime you see fencing, we know, sorry about that. Got a little crazy with my marker here. Anytime we have fencing, we know that that is circumference. The amount of frosting needed to cover a cookie. So that's not, we don't put frosting around the edge, we put it over the whole thing, which is area. The amount of crust needed to cover a pie. So crust is over the whole top of the pie, so that again is area. And then the distance traveled in one lap around a circular track. So here's our circular track, one lap around. That's not what everything in the middle, so we know that one is circumference as well. All right, so we're going to use the images at the right. We have a circle with a 16-foot diameter. We have a circle with a 9-foot radius. And so we know the radius here is going to be 8. Now, let's see what we're going to need to know, or 18 is the diameter on that one. 2 different trees are being planted in an outdoor garden. Each tree requires a specific amount of space for the roots to grow. How much more will space 2 require? So basically what we've got to do here is we've got to find the area of each of these. So we know we have 8-foot radius and a 9-foot radius, and we just need the area of both. Okay, so let's plan our work. We need area equals pi r squared. So that's what we're going to use for both of them. So 3.14 times 8 squared will give us 1. And 3.14 times 9 squared, 3.14 times 64, and 3.14 times 81. And our 2 amounts are, the area for this one is 200.96. This one is 200, and I'm just multiplying here, 254.34, and 254.34 minus 200.96. If we subtract them, we will get 53.58 feet squared. And that is the end of our lesson. I'll go back in case you need to finish writing. If you need any help, send me an email. See me in class. Don't forget, if you're not sure how to use that square root button, let me know and I'd be more than happy to show you. All right. See me for questions and you may move on to your homework.